Good afternoon and welcome to this live session of the course on hydrogen energy. So far, we have been learning about the different methods of hydrogen production. And I hope that you have been enjoying this course throughout. I could see in the discussion forum that there were several queries related to the transcript. Just to inform you all that these transcripts we will be uploading very soon, and you will get that material for studying. So today in this session, I will be taking up your questions, your queries, which you have for the previously uploaded lectures. I will take up these questions one by one. You can keep on posting these questions. So the first question is about the green hydrogen versus blue hydrogen. So the question being asked is that whether the green hydrogen via electrolysis will become feasible. In this course, I have mentioned that the current hydrogen production is through fossil fuel route, and most of it is blue hydrogen. However, the green hydrogen is getting in pace, and that is the electrolysis route, wherein we will be able to produce hydrogen without any emissions. Now, about its feasibility, there have been several reports. I would request you to go through the different reports which are via in IEA. There are reports wherein they have mentioned how the costs are going to come down, and in how they are going to get feasible over a period of time. So there is a short term wherein the blue hydrogen is going to dominate. Then there is a transition period wherein the green hydrogen will rise, although you can see the recent surge of interest towards green hydrogen based technologies. And then later on, what is expected is the feasible. It is expected that it will be feasible by 2030. But then there will be several parameters which will determine the choice of green hydrogen as against blue hydrogen. So not only the technologies, but the economics will work. So the next question I could see is about starting a business in this area. This is a very good time, I will say, because of the interest, global interest, which is there in the field of hydrogen. It is, as I mentioned in the beginning of this course, this interest is everywhere. It could be seen from the government side, it could be seen from the various stakeholders side, from the policy makers, from various industries side. So there is a lot of funding available. Yeah, it is correct time to start a business in this particular stream. The next question is about green hydrogen through water electrolysis is cost effective in future. Availability of water is a future challenge. Yes, if we compare the cost associated with the production of hydrogen from electrolysis route, it is at present not economically viable. But with the economies of scale, and if you could have seen in the different lectures on electrolysis, we have also seen that how the cost is going to come down. It's both from the technology side, the materials cost, the systems, the balance of plant cost is going to come down. At the same time, economies of scale will also bring the cost down. Yeah, so rightly pointed out that water availability of water could be a challenge. And there are definitely water deficit places wherein performing using water for electrolysis could be a problem. So there are now technologies being developed by the researchers wherein seawater can be used. With seawater, there are certain challenges, and those challenges are being addressed with the current research so that the seawater could be used for electrolysis. This course helped in getting job. You will definitely gain knowledge regarding in the field. Which sector is the earliest to adopt blue or green hydrogen at scale? So if you see the major focus currently, there is a lot of interest towards vehicular application, but stationary applications are going to adopt hydrogen at a faster scale because there are competitors also available for vehicular application. Among the sectors, there will be many parameters that we will be discussing towards the end of this course, wherein we will be seeing what is the progress in different sectors, how they are going to adapt hydrogen, and what will be the feasibility of their adoption. So there are many parameters that towards the end of this course, we will see the global scenario, the Indian scenario, and the different sectors, including the different industries, whether it is chemical industry or refinery, or whether it is the power generation sector or domestic applications. So all those we are going to see.
How economic is turquoise hydrogen production using sweet high temperature of -100 degrees Celsius?
100 degree, actually production of turquoise hydrogen, that is in fact methane decomposition, because methane, it is a very stable compound. So its decomposition will definitely require a high temperature. And even if with the use of a catalyst, it is difficult to achieve decomposition at the mentioned temperature of 100 degrees centigrade.
When fuel cells and hydrogen fuel cell will be completely dominating the fossil fuels?
Hydrogen fuel will be complete. So the next question is being asked is when fuel cell and hydrogen fuel will be completely dominating the fossil fuels. It's still a long way to go, but we could see the adoption of these technologies. And as I have already answered to this question, that there are many parameters which will drive this transition. Actually, this is after the wastewater treatment plant, the green hydrogen, it can be, yeah, it is. So what you want to, actually what is being asked is, the green hydrogen can be obtained after the wastewater treatment plant, yes, but the quantity of that will be very less.
Can we use the hydrogen in existing IC engines in the gas turbine?
Yes, definitely. The next question being asked is, can we use hydrogen in existing IC engines or gas turbines, or the engines to be designed new? Yes, definitely the hydrogen can be used, and you have a lecture on this wherein we will see how hydrogen can be included as a fuel for IC engines, and there are certain modifications that also will be discussed in this course. In electrolyzer at constant temperature, pressure, atmospheric temperature, hydrogen and oxygen will recombine under which conditions and pressure? Actually, what is desired is that these should not combine. So if you have seen the different configurations, the purpose of having two separate electrodes with a separator in between is that they should not recombine. Although there is crossover, small crossover, that is always required to be minimized. So, and we have also discussed that under high pressure conditions, there are how this affects the crossover. So what is actually required is this crossover should be as low as possible.
Hydrogen, energy modeling techniques.
Actually, we won't be covering the energy modeling techniques, which is being asked as one of the questions in this forum. We will, however, be looking at the systems modeling for only hydrogen storage system in this course. Next question being asked is, can we use hydrogen fuel for aircraft engine? Yes, hydrogen is being considered as an aviation fuel. There are still certain challenges. There will be certain design challenges. There will be certain so compared to using pure hydrogen, there will be alternates that will be more feasible when it comes to as a aviation fuel.
Electrification or use of hydrogen fuel in auto industry, how we are using the power of fossil fuels.
With electrification or use of hydrogen fuel in auto industry, how we are using green energy when both the power generate from fossil fuels. Actually, this question is not very clear. It has been asked that green when both the power generate from fossil fuels. Yeah. So current, actually, your question is like, it is not then green energy. So if both hydrogen and electrification, the energy being requirements are being met from fossil fuels, it's being rightly mentioned that it is not a green method of production of hydrogen, and the overall hydrogen energy value chain will not be green in that case. That's why there are different color codes assigned. Blue hydrogen or brown or black hydrogen, these are not the sustainable methods or sustainable forms of hydrogen. And if we are producing still from fossil fuels, we are emitting at the different points. Only the green hydrogen being produced, that could reduce the emissions.
Can you suggest some methods of CCS because the industry is already working with grey hydrogen and
for CCUS, you can see different ways. There are different ways for carbon capture, use and sequestration. Yes, industry, but CCUS also have certain limitation because the quantities of hydrogen which are currently being produced both in India and carbon dioxide or the emissions being released to capture that and use that is very difficult. A fraction of that we are currently doing. But then again, the adoption of CCUS completely to take care of these emissions is having both infrastructure related as well as there are many challenges associated with it. And economics also industries will consider. Next question is to discuss about design of PEM electrolyzer with a standard design code in upcoming sessions. We have discussed about the PEM electrolyzer basic design, but very specialized design, maybe another course could be offered, but not in this course, because this course covers a vast variety of topics.
Is PEM technology evolving so that it can be dominant over alkaline?
PEM, so the next question being asked is PEM technology may dominate over alkaline? we have seen there are many advantages of PEM electrolysis technology over the alkaline electrolysis. And yes, the cost is the major hurdle. Else, there are many advantages and it can dominate over the alkaline electrolysis. Can we recover hydrogen from tail gas using hydrogen membrane? We can recover, but in the tail gas, the process technology wise, it's not a problem. We can recover, but the amount of hydrogen in the tail gas is very less. It's negligible, it's very small. So yeah, we can recover it.
In India, which is the widely method for hydrogen production?
So I have also given you the numbers in the course. And yes, in India, the major method for hydrogen production is steam methane reforming.
Is it possible in India to store hydrogen underground?
Geological storages. So there is another question wherein it has been asked that in India, is it possible to store hydrogen underground? We will see in later part of this course when we will talk about hydrogen storage, the different methods of hydrogen storage and the constraints that we have. So what are the different types of underground storage, the availability of these, and what are the different constraints associated with that we will see in detail.
Please explain how we achieve pressure greater than the atmospheric pressure in PEM or alkaline electrolyzer without external compression.
So there is one question which has been asked in discussion forum that how we can achieve the differential pressure in the PEM electrolyzer. So if you remember, we have seen the geometry or the construction of the different types of electrolyzer, and then we have seen that there is a membrane which separates. There is a separator which separates the two compartments of the electrolyzer, and that not only reduces the crossover, the intermixing, but at the same time you can have differential pressures also. Now it is like if in a compartment, if you keep on pumping more and more, the pressure will rise. Now this separator ensures that there is no crossover. For PEM, this is more compact, and in that compartment you can achieve because of the compactness of the separator and the compact design as well.
Is GCV of a fuel different from HHV or LHV? Different from higher heating value or lower heating value?
When it comes to like you code generally in terms of higher heating value or lower heating value, the difference is that if you have considered the entire energy content, including whether it is in the form of steam, water you are getting. So then it comes, usually the reported ones are the higher heating value. And if it is not included, then it is the lower heating value, the other energy components.
Which is a suggested way of comparing efficiencies of various technologies. SMR uses thermal energy and electricity.
So the next question being asked is, which is the suggested way of comparing efficiencies of various technologies? SMR, which uses thermal energy, and PEM, which uses electricity. So whatever is the definition of efficiency, you have to include whatever you are getting as output to the input. Now herein, whether it is in the form of thermal energy or whether it is in the form of electrical energy, all the inputs you have to include. So the next question is, in future solar or wind or hydrogen hybrid plant, is it possible to balance energy conversion? if I could rightly understand from your question, you want that what exactly it will look like, or if it is integrated with renewable energy, then how it is going to take care of the intermittency. So if that is the question, or you can again ask, because your question is not clear, that in that case, hydrogen hybrid plant, yes, definitely it could be a solution.
How to maintain the pressure and temperature?
I think that how to maintain the pressure and temperature of PEM, that I have already answered.
Is a limit of temperature to store the hydrogen in gaseous form only?
Usually, so the another question being asked is about the temperature to store hydrogen in gaseous form. So the tanks which are used for storing compressed hydrogen are usually kept at room temperature. However, during the filling up of these tanks, or during the hydrogen being filled, or getting that hydrogen from these tanks, the temperatures may vary because of the obvious reasons that we have discussed. So there are certain standards to which they have to comply. And all these standards, what will be the associated temperature, what would be the tests, we will be discussing when we will be talking about compressed hydrogen storage.
Next question is asking, what should be the water properties in the pH hardness per monitor for efficient PEM electrolysis? What are the main issues faced or parameters to be monitored during normal operation of nitrogen production using PEM electrolysis?
That use for water electrolysis.
What is the color of flame of nitrogen?
You can ask question on this. Invisible flame. If there is no other contaminant, so if something else also burns along with that flame, let's say if there is something kept in the surrounding and in a hydrogen flame that burns, so in that case, because of those volatiles released, you may see some smoke or some color, but actual hydrogen flame is an invisible flame.
In refineries, SMR via grey hydrogen route is prevalent. How can we transition to green hydrogen in refineries by integrating solar energy or other effective means, mainly for refinery scenario?
Yes, so in refineries, currently it is SMR which is being used. However, refineries are looking at use of hydrogen, green hydrogen. So they are currently looking at green hydrogen through electrolysis route, and this may take up in future. So this is being considered. It's being considered by refineries, whether several industries, chemical industries currently, but it is the production route is So for the question is that why we are using high temperature water gas shift in case of PSA. So high temperature water gas shift is actually integrated in a SMR production plant to extract more of hydrogen and to convert CO to CO2. So that's why it is the carbon dioxide. So it converts into more of hydrogen. So extra amount of hydrogen can be extracted, and then CO2 which is being formed can be removed. And we will also see that how we can have the PSA with different sorbents, and some of these gases are easy to remove. In fuel cells. So we will be covering a portion of hydrogen utilization both in fuel cell as well as IC engine. we will be describing in more detail at that point. Yeah, you can post questions on the forum. At present, I've seen the on network.
So is it possible to reduce CO from 15 ppm to 2 ppm and methane from 1500 to 5 ppm by membrane method cost effectively? Like we are facing hydrogen purity issue in our plant.
So the purity of the outlet stream and the constituent of the composition of the different gases will depend upon the membrane selection, and need to see like which membrane to be used to reduce down to such a high purity level. Yeah, so there was a connection, there was a disconnect in between. You can keep posting your questions on this forum.
Selectivity and diffusability.
This has been defined in the. So there is the question about the selectivity, permeability,
And diffusability.
and diffusivity. So the terms themselves, although we have already defined in this course, so the terms themselves, they tell about this. Please go through the videos to see we have already defined. So it is the amount which is permeating. So the exact definitions we have already mentioned in the course.
What the electrolyzer, how much potassium hydroxide purity requires, and which grade of this is required for alkaline water electrolyzer?
That is also mentioned.
What if hydrogen and oxygen generated without separator in electrolyzer and stored in combustion?
Actually, we cannot. So it is being asked, what if it is hydrogen and oxygen are generated without separator in electrolyzer? That is not possible. And if maybe in fuel cell, we will be talking about more about it, that the basic function of fuel cell or electrolyzer, they are the two different devices which operate opposite in action, but they are both the electrochemical devices. The major part is that they should produce or use hydrogen. So it should produce electrolyzer. In fact, let us be specific about electrolyzer. They should generate hydrogen and oxygen separately. That is what is the requirement. In fact, we avoid any conditions wherein it could form a flammable mixture.
And we design our own. So what are the consideration permission test needed to be?
For designing your own PEM electrolyzer, I would suggest you have to first learn about, you need to first get technical training for that before going for such designing or fabricating the electrolyzer.
This question is coming very quickly. So please suggest good books to begin with hydrogen storage.
So about the books, again, I would like those who have joined late, I would like to mention the transcript for these weeks will be available soon. Regarding the books, we have floated in the course introduction. There are certain books already described as references in the course introduction. Please go through those. That will help.
Yes, the question hybrid series civil cycle.
I think it something.
How pre-reformer increases efficiency of plant.
So the use of pre-reformer, we have seen in detail that it serves several purposes. One is we have seen that steam to carbon ratio, it can regulate in the next part, which is the reformer itself. Secondly, it can convert the more reactive components which could decompose to form coke onto the catalyst and can produce methane. It can convert these higher hydrocarbons into lower hydrocarbons. The requirement could be in the primary reformer, then the requirement will be of S/C ratio lower when it is a pre-reformer is used. So it serves several purposes if a pre-reformer is integrated with the steam methane reformer.
Can existing network of natural gas pipelines effectively used for transportation?
Yes, the existing natural gas pipeline network can be used, but to how much percentage the blending should be done, that we will see when we will talk about the transportation of hydrogen in this course.
Cracking reaction of high hydrocarbon to methane. What can we do next in Aviation?
So a question from the student's perspective, as I could see, is one I could see repeatedly is the internship. Yes, you can approach for internship. There are different institutions wherein there are different faculties who are working on hydrogen. You can approach them. You can also write to me. We will see. Based on your interest, you can join. You can get internship. Another question I could see is what can we do next in line with this course? What are the directions available to move forward in the field of hydrogen as a form of energy? If you are interested in, depending upon if you are a student, you can pursue your career further. You can join for a higher degree and then do a specialization in this field, or you can do research in this area. And so there are different possibilities. There are different opportunities. I could tell based on what is your interest, and so you can write back to me.
This question long. I could not appreciate it, but typically I'm guessing that solvent cleaning using MTEA means about 40 degrees Celsius temperature. So might as well use low temperature shift.
So it's being asked that if you are using solvent-based removal, you will be using low temperature water gas shift. Yes, that is correct. You will be using both high temperature and low temperature water gas shift if you are using solvent-based cleaning method. So it's a question on whether you are working with industry. Yes, I am jointly working with several institutions and industries to basically on hydrogen storage.
One of the major uses of carbon black is studies which type of carbon is most efficient for this application and which process or catalyst makes this carbon. Which shape of hydrogen storage tank is best, vertical or spherical, regardless of area?
So the best for hydrogen storage, now depending upon, so there are different conditions. When it comes to, we will see in more detail when it comes to compressed state storage, we will have to see which way the tank, the stress concentration regions in the tank. So it comes from both the technical aspects as well as the manufacturability of these type of tanks. When it comes to liquid state storage, we know the boil off is the major challenge, and all these things we will see in more detail when we will talk about hydrogen storage. We will see that how the surface to volume ratio affects and how the design will change. When it comes to solid state storage, the design considerations will be different. So different methods will have different design considerations, and we will see in more details in the later part of this course.
How about the high NOx production rate with hydrogen burnt in air, another hydrocarbon?
So the next question is about the NOx production in when hydrogen is being burnt in air as against the hydrocarbons. That will be covered in the later part of this course. So some of the questions are being asked are related to the later part of this course. I would suggest that you go through those, and then still you have doubt, we will be talking about those in the later live sessions. So in IC engines, we will be looking at those, the use of hydrogen in IC engines in detail.
Can you throw some light on the future of metal hydride hydrogen storage?
The another question being asked is again on a topic which we will be covering later in detail. That is the metal hydride based hydrogen storage. It's future of metal hydride based hydrogen storage. If you see the technologies, how these are adopted, this is a very dynamic situation which is currently we are in, and the scenarios are changing. However, the use of metal hydrides currently it is specifically it could be applicable for stationary applications. However, their use for vehicular application is also being investigated.
Will the final exam be descriptive or MCQ? There are like lots of discussion forums. So skills. I want to start my project in hydrogen production by electrolysis, but in using technology.
You can post your questions on the forum.
Question about what is catalyst settling and what is catalyst loading.
Okay, so there is a question being asked in the forum earlier about the settling and the loading.
Catalyst settling, catalyst loading.
By settling, we means like after several cycles, the homogeneous distribution of catalyst is not there. That means you have certain regions where it is the concentration of catalyst is more compared to the other regions. However, while loading, that is how much percentage of it is being used on a support or being used for, that is expected to be more of homogeneous. So loading is how much percentage of it you are putting in and it is expected that it should be homogeneous for efficient performance. However, after several cycles, it could settle down. That is an aftercome of a particular process. Just any other question you can, if you have, you can post here. Yeah, the next question being asked is liquid hydrogen transportation through vacuum jacket piping using standard code. Actually, the question is not clear. Yes, it is being liquid hydrogen transportation has to be carried out in highly insulated, super insulated vessels. That has a vacuum jacket. There are codes available for that. And the standards codes we are going to see in the later part of this course. Which type of pump and compressor?
Yes.
That is also being covered in very much detail. If you will see the course contents, we will be covering the working principles, what are the different types of compressors, their efficiencies, the work of compression, all that in detail when we will talk about the storage aspect.
Carbon formation decreases pressure as the cross section decreases inside the tubes. The same question.
So one of the question being asked is how the carbon formation decreases pressure. So what happens is if you can visualize that these are in reforming, let us consider that we have catalyst filled tubes, bundles of tubes. And this is a sort of, let us consider like this is a sort of porous media. There are multiple pores available which are for the flow of different gases. Now, when there is carbon formation, it will block those pores. As such, the flow of hydrogen will decrease. So there will be, it's one of the outcome of coke deposition. There are several other challenges which comes when there is a coke formation, that also we have discussed.
Which metal is favorably chosen to construct hydrogen pipeline?
For hydrogen pipeline, let us wait for the transportation part. We will be discussing that.
What is the use of gas trap in vacuum jacket piping for liquid hydrogen? Strap in vacuum. Why carbon paper is used in fuel cells?
Let us look at the questions on hydrogen production in this live session, because many of your doubts which you are asking, you will be able to understand better when we will look at the other later parts of modules of this section. Let us concentrate on the production part, whatever we have covered till this part.
Current conventional SMR process and get the minimum number of.
So another question is about the modification. Can we modify the current conventional SMR process? Yes, we have also seen some of the modifications already. The absorption enhanced reforming, that is again a modification of it. The hydrogen membrane reactor, Advantages of each of these methods also we have seen in more detail. Regarding research paper, so we have already discussed about the different technologies which are the modifications of the conventional SMR in the course. So the next question is about fuel cells. Yes, fuel cell we will be discussing. We will be talking about fuel cell, the different types of fuel cell, the principle of operations, and the different structures and all in the fuel cell part of this course.
We have discussed only on industrial production of hydrogen. Why can't we use it one of the technology in domestic purpose?
So another question is related to the industrial production of hydrogen. So and it's being asked that why cannot we use it in one of the technology in domestic purpose? In the beginning, I told that in this course we will be concentrating on the methods of hydrogen production which are at industrial scale. But the method which can be used, it's not that method can be used only at industrial scale. It can be used at domestic. But then how does the economies of scale work when it comes to cost reduction? And the selection of technology may be different. As I have already mentioned in the beginning of the production part, that setting up a SMR for domestic application may have certain technical challenges compared to having an electrolyzer for a tabletop electrolyzer for producing hydrogen for a small scale application. So the choice, it's not that you cannot use these methods for domestic or the small scale hydrogen production. It's only which technology you are going to use, and the choice of technology also. By the end of the production part, you will be able to understand that which technology would be effective under what conditions.
To match a gas station selling around 4,000 liters of petrol or diesel in a day, what should be the capacity of the electrolyzer? And how much should be the production of hydrogen?
Actually, this could be another question being asked is that if gas filling station which sells 4,000 liters of petrol diesel in a day, what should be the, I think this is a simple calculation which you can do. Capacity of hydrogen, you can consider like what would be it's being asked is what is the capacity of electrolyzer which will be required and how much hydrogen will be produced. You can do based on the energy density of the gasoline or diesel or hydrogen, and accordingly you can calculate how much will be an equivalent amount of hydrogen which will be required, or which will be equivalent to that in that gas refueling station, and accordingly you can calculate the capacity.
Question is asking that PEM will be preferred over electrolysis or
so there are different, actually, if you compare PEM and alkaline, we have already, that comparison, if you see, we have already seen. PEM is preferred under certain conditions and alkaline is preferred under other set of conditions. Now the determining factor is like the power density. If you see the differentiation, we have already seen in terms of the power density. We have seen in terms of the outlet pressure which we are going to get. We have seen in terms of the cost. Now, herein which technology is going to dominate? There are several parameters which are going to determine. Also, what is the end use? That also is going to determine which of these you are going to use. So if you see in the current scenario, yes, it could be alkaline being more economical compared to PEM. But then depending upon end use, there could be applications wherein PEM could be preferred over alkaline. But then it could be at a higher cost as well. So that all depends upon several parameters, and based on that, it won't be correct to completely rule out one of the technology and say that this would be the preferred one, but you have to judge that in the light of different parameters.
How to calculate the increased temperature
Okay, so next question is about increased temperature rise when you are compressing hydrogen. So that is taken as a problem in the tutorial. You will see in the next week, I think you will see that how you can find out that.
Coming back to efficiencies, I calculate from energy of reactions. The theoretical energy used in electrolysis is 3 times more than in SMR. Does this match your estimate too?
It's the energy of reactions, the theoretical energy required for electrolysis is 3 times more than in SMR. Yes, it's 3 plus. Exactly, I will have to tell you. Maybe I can post that in the as a mail to you. I have to check and then I will get back to you. But definitely it is 3 or 3 more than 3 times.
Confusion between where to use metals and where to use this means how it works with the decomposition.
Relation to?
Hmm?
This is related to which part? You can keep posting your questions here. We still have few minutes left. Yeah, any other doubt if you have, you can please post.
Production making decomposition. 14 directly pointed out. All lecture is typed.
That I can see separately. Yes, if any other question, you can post here on the forum. The time frame is being asked when we will be using green hydrogen like petrol as fuel. So it's exactly difficult to predict what exact time frame. But slowly we could see the adoption towards green hydrogen is increasing, and the interest from the industry side as well is increasing. But how this will be driven by several parameters. One is definitely the reduction, the requirement for reduction in the emissions. Then there will be mandates that will be from the government side. There will be advantages of adopting green hydrogen that the industries will see, and all that will make difference. But in current scenario, telling exactly which year it's going to substitute for petrol or diesel will be very difficult. The prices we could see are coming down. The scales, if you see the electrolyzer, the capacity we are talking about have increased from kilowatt scale to now we are talking about megawatt, and now even planning for gigawatt scale electrolyzer. So all these are going to make difference in future.
Can you take a small session on electrochemistry?
To discuss about Faraday's laws or electrochemical basis will be little difficult. Maybe as a part of another course could be planned, but not as a part of this course.
In hydrogen production calculation, production is basically equivalent to current in the circuit. Is it correct? Does voltage have any role in the quantity of hydrogen produced?
I think that is there. Do you discuss about cryo-compressed storage?
In the upcoming session. Yes.
Okay, so another question is about the cryo-compressed storage. Yes, we have discussed about the cryo-compressed storage. We have, in fact, in the course, you will see that compressed storage and both cryogenic storage has been discussed at length. In compressed storage, we have talked about the different compression mechanisms, and in cryogenic, how is it liquefied? And at the after that, we have even discussed about the cryo-compressed, wherein both the requirements for the compression, where it is very high pressures, could be lowered down. At the same time, the requirement of having super insulation could also be relaxed with the use of cryo-compressed tanks. And that also we have discussed in the storage part.
As per government vision of green hydrogen as a future fuel, is it possible to start green hydrogen as a fuel by 2023?
Again, this is actually a repetition that what time frame we will be starting to use green hydrogen. It's that already green hydrogen has introduced into the economy. It's being, the interest is there. It is the electrolyzers. These are, the technology is in place. The deployment is going on, but which year it's going to substitute any fuel, it is very difficult to say. How the progress will be there, how how well these economies of scale, the policies will work out. So to exactly tell the time frame will be very difficult. But yeah, definitely it's progressing well, we will say. Yeah, any other question if you have? You can post on the discussion forum, and we will, some of the questions, if there are earlier being posted in the discussion forum, and if we could not reply, we will reply to those as well. And you can keep your doubts posted in the discussion forum. We will take up one last question.
I was Can we invest in hydrogen stocks?
So one last question, can we invest in hydrogen stocks? I will not comment on it. Okay, thank you. Have a great learning, and you can post your doubts further in the discussion forum, and we will try to reply all your queries there. Thank you.